If you take the one that is marked minus 2000 BC to 2000 AD.
Right.
Here you can see the fluctuations in temperature. This one is taken from various core samples, so we can see the delineation of the temperature anomaly. So what we see here is that from the Roman warm period, which occupies the point in the middle here, you have a high point that goes from around 500 BC and then upwards, and then it plunges down around the year 0. And this is probably due to a series of volcanic eruptions, rather big ones, that created a region of time where there were several years without a real summer. It was shrouded, the entire planetary body, in dust. So as you can see, the temperature plummeted dramatically. There were mass famines, and this is also where one of the large plagues that really knocks the Romans down quite a bit else. And then you can
just quite a dramatic shift. Interesting.
So what you see here is then essentially how high culture follows these warm pages. You have from the 2,000 years ago, when you have the early rise of the early Bronze Age, and then we go into the Minoan warm period, where you have the large Bronze Age trade and civilizations in the Mediterranean basin. And then it gets rapidly colder again, and then, well, people starve, and it all goes to shit.
Right.
And then you have the Inter-Hellenic period there with the Greek Dark Ages until the rise of the Roman Empire, or rather first Roman Republic. But you can see even in the so-called Greek Dark Ages that goes between there, if you go out through towards modern times, you can see that it's substantially warmer than what it is now. And if you go into the medieval warm period, this is where you have essentially around the year 1000. This is where every cathedral in Europe is built, because this gives the population and agricultural surpluses that you have the time and resource to spend on building cathedrals.
Right, that makes sense though. But I mean, we did talk about Evola a minute ago, and he does talk about these cycles, right? He calls it like the Atlantic cycles or something. Let me see. I have the book here next to me, actually. Let me just pull this up. I can at least get the chapter name. The Northern Atlantic Cycle, the Pole and the Hyperborean region, the North and South. In some of these chapters, he talks about, how these things. He has it's not graphs, but like arrows showing how these cycles work, and it almost seems to match up with the temperature here. But if you're gonna follow his line of thinking, it's ever going downward. It's just an interesting thought.
Yeah, the thing is that if you follow this kind of thing, especially as Evola points out, you go through periods because the temperature of the Earth, also because how it interacts with the orbital cycles of both the Sun and the planetary system, it goes through periods of warming. It goes from warm to cold, constantly bouncing back and forth. Some periods are shorter because of orbital dynamics and the regions that the solar system travels in. That is also one thing that people doesn't really take into all these climatological models that they have. But it's like, oh, but if there's a cycle, they say, why is it this way and this way? And more modern astrophysics is starting to realize that the galactic bombardment of charged particles has quite a large influence on planetary weather, not just on Earth, but on the rest of the planets in the solar system. And since we do pass through the galaxy slowly, this means that as we pass through these distant regions, the solar system is then exposed, if you will, to different types of space weather, within quotation marks. So it's like trying to use a line, what the IPCC, for example, is trying to do when they're measuring quote-unquote climate change, is essentially trying to use a linear directional model in a complex systems where you know where you know about 15% of the variables, rest are just knowns, which means that every time you get one number wrong, it creates
the deviations are huge. Yeah,
and the deviation by each is then cycling off that data becomes one standard deviation upwards. So once 3 wrong numbers that have gone through 3 cycles, you're at 9 standard deviations of fault. So, and that's why they are constantly making these insane predictions that never really seems to hit the ball, and that is because they are having a very faulty model.
Interesting. Not to get all Evola again here, but Julius Flavius says he does speak of them being a people in a place who gave way to lunar-type people who eventually set up colonies in the east. Yes, he has the north to south and west to east migration patterns, etc. But I think our points was more that it's not like he's trying to prove, that the meme Hyperborea that we talk about today actually existed. It's more that he's trying to explain how this greatness was lost or diffused over time. Anyway,
yeah, essentially.
Sorry. Yeah.
No, I was just reinforcing your idea that he has, since then, in a sense, using it as a rhetorical device to comfort the ideas of the cycle of the yugas.
Yes. Okay. Do we have is it time for another graph or?